All right, here we go. So sentences involving x, the absolute value of x minus k. Um, let's get after it. All right, so if we had, for example, x minus 5, absolute value of it is equal to 3, then this number is either going to be positive or it's going to be negative, whatever x minus 5, that quantity is. If it's a positive, then it's going to be equal to positive 3. So x minus 5 equals 3. Add 5 to each side, and we get x equals 8. However, if the quantity x minus 5 is a negative number, then whatever this is going to be equal to negative 3, because then if we took the absolute value of that negative 3, it'd become positive 3 and would be equal to 3 here. So to find out what x minus 5 is, since again we know it would have to be equal to negative 3 if it were a negative number, then let's set it equal to negative 3. We add 5 to each side and get x equals 2. And there's our solutions for this first one. So the distance from, now just reading through the meaning here, so it says the distance from x to 5, so from the difference from x to 5 is 3 units. And so let's go ahead and, before it was 0, now we're having 5 be our center. And so here's 5, and then our two numbers are either 3 higher, so 8, or 3 lower, 2. And so there's our solutions, 2 or 8. Next we've got, actually let me print this one up over here. So we have x minus 1, done with that first one. X minus 1 is, absolute value of x minus 1 is less than 2. And so how are we going to deal with that one? So we have the absolute value of x minus 1 is less than 2. Now if this value in here is positive, then x minus 1, whatever it is going to be less than 2, just like it says here. And we'd add 1 to each side and get x is less than 3. All right, that we can graph fairly straightforward. So we've got so we got 1 in the middle. Oops, not 1. So you're putting 0 there. And you could put, actually, you could put 1 there if you wanted to graph it that way as well. But we'll go with 1 in the middle. And then distance of 2 away from it at 3. And it's going to be less than, so coming this way. On the other hand, I wrote a positive here earlier. On the other hand, if x minus 1 is a negative value, then whatever it is greater than 2. So x minus 1, if it's a negative value, then it's greater than, negative 2. I think I might have misspoke about that earlier. We'll add 1 to each side, and we get x is greater than negative 1. All right, so negative 1, and not included is not or equal to, and it's shading to the right towards the positive numbers. And here's our solution set from negative 1 to 3. Those are all solutions. Now, when it's an and situation, you can write it just like this right here, where negative 1 is less than x, which is less than 3. Or you can write it as x is greater than negative 1 and x is less than 3. Just make sure you get the word and in there if you're going to write it out that way. Next we have x plus 3 is greater than 2. So here we are. If it is a positive value, then we have x plus 3 is greater than 2. Nothing changes at all. We subtract 3, you get x is greater than negative 1. So this time we'll put negative 3 in the middle, and negative 1 would be to its right, so negative 1, and shading to the right where numbers are, x values are bigger than that. On the other hand, if x plus 3 is a negative value, then x plus 3 would be less than negative 2. Because if we were taking numbers less than negative 2 and making them positive, they would be greater than positive 2. Subtract 3 from each side, and we get x is less than negative 5. Here's negative 5 on our graph. Open circle, shading to the less than. And so, again, that if you were here, we've just got equal. the less than is going to be your and situation, where you're looking for both to be true. The numbers in the middle of them are the solutions. And where it's the absolute value is greater, that's your greater situation, just as a little kind of shortcut. All right, and just down here the notes, we'll just read through it quickly. Just kind of some generic form of this, of the absolute value and of the inequalities. We've got the absolute value of a times x plus b. And so in these cases, you're going to be setting it, ax plus b equal to positive c and ax plus b equal to negative c. And then once you've broken it up, solving for your two values. These you'll all handle just the same as above, and so we don't think we need to go through that quite again, but here are some equivalent sentences for that. And just as a reminder, for the and, you can write this as ax plus b is, well, actually you would solve for x first, but you can write the ands with an and as well. You don't need to write it as that compound inequality, but just whatever is easier for that situation. So, all right, hope that helps.